In this video we're going to find the max and min turning points of a function. Okay, so I've drawn what a function would look like there on an x and y axis. That green line here. So that's a function, a cubic function. You could also have a quadratic function. A quadratic function might look like this, or like this. And the turning point is basically the place where the function turns. So on the one on the left hand side, there's the turning point. On the one on the right hand side, there's the turning point. And the one in the middle, it's already highlighted, there's the max turning point, and there's the min turning point. Okay, now on this one over here, it only has a max, it doesn't have a min. And on this one over here, it only has a minimum turning point, it doesn't have a maximum turning point. These ones here would be a function that has a minus x squared in it. This one here would be a function that has a positive x squared in it. And the one in the middle, the one that looks like a snake, they are cubic functions, so they have x cubes in them. And that's what they look like when you draw them. Now, you're not really asked to draw them in these questions. It's just helpful to know what they look like. So we're going to try and find the actual coordinates of these points when you're given the function, you're given the equation. So here's a sample question for a quadratic function. Quadratic meaning it has an x squared in it. Okay, and you can see the x squared there. It doesn't have an x cubed, it just has an x squared. So find the turning point of the following quadratic function. You notice it says turning point, not turning points. It just has one turning point. Quadratic functions just have one turning point. It'll be either a max or it'll be a min. And the function is given there as y equals x squared plus 2x minus 1. Now, how do we actually do it? What are the steps? Well, the first thing you have to do is you have to differentiate the function. Okay? Now, if you're not sure of how to differentiate, look at the previous video on how to differentiate. Okay, so let's differentiate this function here. How do we do it? Well, the power multiplies by the number in front. Now, there's a 1 there, you just can't see it. So 2 by 1 is 2, and then the power reduces by 1. But of course, we don't write the 1. Plus, and then numbers that just have a letter with them, they drop the letter. So it's just 2. And numbers that are on their own disappear. So that's gone. So that's it differentiated. That's what we would call dy dx. That's the differentiated version of the function. Now, again, if you're not sure of how to do that, of how that actually works, look at the previous video on how to differentiate. Okay, so we've differentiated. We've done step 1. Now, step 2. We have to put it equal to 0. Put dy dx equal to 0. Put the thing that we just found equal to 0. Well, that's straightforward enough. We just say equal 0. Step 3. We solve it. Now, how you solve it depends on what kind of function you started off with. So if you started off with a quadratic function, like we did, well then you'd simply, the next step is simply getting x on its own. Get x on its own. Now if we started off with a cubic function, and we'll do one of those in a minute, then you would use the minus b formula. Okay, because you'd still have a quadratic equation. But we don't, so we're just going to get x on its own. So leave x there, and bring that 2 over to the other side. It'll become a minus 2. Divide both sides by 2, because that'll get x on its own then. X is equal to 2 into minus 2, minus 1. Okay, so now you know what x is. What do we do now? Step 4. Sub this answer. into the original function. The original function we were given in the question. Sub minus 1 into this function. Okay. So we'll have minus 1 squared plus 2 by minus 1 minus 1, which is 1 minus 2 minus 1, which is minus 2. Now we have the coordinates of the turning point. Our x coordinate is minus 1, and our y coordinate is minus 2. We just got it there. So that is the turning point. That's where the function turns. And it's just those 4 steps. Okay, so we'll try another one, except this time it'll be a cubic function. So find the maximum and minimum turning points of the following cubic function. Again, a cubic function is one that contains an x cubed. That's why we call that a cubic function. And these ones are slightly longer to do because, like I said a moment ago, you're going to have to use the minus b formula. And I'll show you why in a minute. So it's still the same steps. First thing we do is we differentiate. So the power multiplies by the number in front, so that's going to be 6. And then the power reduces by 1. The power multiplies by the number in front, and it reduces by 1. So 1, but we don't really use the 1. Numbers that just have a letter, drop the letter. And numbers that are on their own disappear completely. So that is dy dx. That is it differentiated, dy dx. Step 2, put dy dx equal to 0. So let's put it equal to 0. Step 3, solve. Now, getting x on its own won't work in this because you have an x squared and you have an x. So they won't tidy up. They won't add together. So it won't work by just bringing numbers to one side and x's to the other. For these cubic functions, that's why you have to use the minus b formula. So we still have a little bit of work to do. Minus b formula. A, b, c. Remember, a is the number in front of x squared. So a is going to be 6. B is the number in front of x. So b is going to be minus 6. And c is the number on its own. It's going to be minus 12. So fill those all in to the minus b formula. Minus b formula is given in the logbook. It's helpful to write it out first, then put brackets around the letters, and then write it out again, except take the letters out. Right, what letters are we dealing with? Here, B. B is, I never wrote them out here, so A is 2, B is minus 12, sorry, A is 6. B is minus 6, and C is minus 12. So B is minus 6, 6, minus 12, 6. Type it into your calculator. The first time you type it in, use a plus. So we'll do that answer here. And the second time you type it in, you do a minus. You do that answer here. And when you use the plus, you get an answer of 2. And when you use the minus, you get an answer of 1. Okay, so there are two answers. X equals 2 and x equals 1. So that's step 3 done. We've solved it. We've got 2 answers. Step 4, sub in answers. See, for the first question we did, was only one answer. X just had one answer. It was -1. So we subbed that into the original function and we got a y value. So we had one coordinate at the end of it all. We had an x and a y coordinate. So that was 1 point. Because the function only had one turning point. But now we're dealing with a cubic function. It has 2 turning points. So that's why we have 2 x values at the minute. We have to sub each one of those into this original cubic function to get 2 y values. So let's do the first one, x equals 2. So we have, the function is, we do this in red pen, the function is 2x cubed minus 3x squared minus 12x plus 7. That's going to be 2 by 2 cubed. I'm just subbing in the answer I got. Minus 3 by 2 squared minus 12 by 2 plus 7. Which is, it is 16 minus 12 minus 24 plus 7. Which is 16 minus 4 minus 20 plus 7 is minus 14. So now I have my turning point. I'll put it in brackets here. I have my x coordinate, is 2. It'll go in there in a moment. And I have my y coordinate, minus 14. So my turning point is 2 minus 14. That's my first turning point. Now I repeat that again, except this time I sub in my other x answer. So still use the original function, which is 2x cubed minus 3x squared minus 12x plus 7. Sub in the 1 this time. So that's going to be 2 minus 3 minus 12 plus 7, which is 2 minus 1 minus 13 minus 13 minus 13 plus 7 is going to be 6 minus 6. So there's my other turning point. I have my x coordinate, it's going to go there, and I have my y coordinate, that's going to go there. So it is 1 minus 6. So there are my 2 turning points. Now if I wanted, I could sketch this. I could draw just a quick sketch. Let's imagine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 1, minus 2, minus 3, minus 4, blah, 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 blah. Just a sketch now. That's why I'm doing it so roughly. I just want to figure out which is which is the max, which is the min. So 2 minus 14. 2 minus 14 is down around here. And 1 minus 6. 1 minus 6 would be around about here. So my function looks like this. Something like that. So the max is that one, which is this. So that one is the max, because it's the higher one. And the min is this one, which is this point here, because it's the lower one. So whatever's higher is the max, whatever's lower, sorry, max, min, oh god, where am I gone? Min. It's lower down, so it's the min. That's higher up, so it's the max. I just sketched it and I could see that visually. Okay, so here's a couple for you to try. Pause the video now and try those two. One is a quadratic, one is a cubic, and I'll write the answers in a second. But pause the video now. And that's them done there, so you can pause the video and go through those in your own time.